Hi, everyone, and welcome back to the Uncast. As always, I'm your host, Jon Panozzo, and for today's show, I wanted to give you a sneak peek at some of the changes we're making in version 6.10 of Unraid, and talk a little bit about some 10 gigabit performance testing that I've been doing. So a little while back, I authored a PSA blog post about Unraid security best practices, which highlighted a number of things all users should do when they get started with Unraid. The highlights from that blog post include setting a strong root password right away, not exposing your server to the DMZ, being smart about what services you do expose, being smart about share level security, keeping your server up to date, and a bunch of other tidbits. We'll put a link in the description to that blog post if you want to recap. But for today, I want to expand upon this topic by covering a number of changes that we'll be making in version 6.10 related to security. So the general theme of 6.10 is all about security over convenience. We're locking down the OS even more than before and requiring users to think more critically about security. A good example of this is the root password. In version 6.10, all users will be required to set a good root password for their server. This is no longer optional. And the reason is that root access is more than just your ability to connect to the web GUI. It allows you to do anything you want to the entire OS. It is the keys to the kingdom. So having a strong root password to protect it is vital. The next thing I want to talk about is share level security. So in 6.10, we're going to be changing some of the default values of newly created shares. The first thing is that we're no longer going to automatically export any shares you create over SMB. You will have to explicitly choose to do that. And on top of that, you will no longer see public level access set to those shares by default. So what's important to note here is that when you have a share exported over SMB with public level security access, any device that's on the network that has an SMB client has full read and write permissions to that share. So even if you have a good, strong root password on your server, and even if you have that server behind a proper firewall, if a device with an SMB client on the network were to become compromised, that device could be used to corrupt the data on your server because it would have full read-write access. That's the nature of a public SMB share. Okay, so that's why it's important that when we talk about security best practices, it's important to look at your entire network and not just your server, right? So, if grandma's coming over and she's going on the web on a computer that's on your network and she's clicking links that maybe she shouldn't, you should be concerned about that because inadvertently she might end up with some malware, and that malware could target an SMB share with public access just as easily as it could target the C drive. So it's important to keep that in mind when you're thinking about security for the entire network environment. Now, going along those lines, I think we should talk for just a second about what shares on your server really need to be exported anyway, because a lot of folks just, again, leave the default values there, and so every share they create is exported over SMB, but you might not always need to do that, or maybe if you do want them exported, maybe a couple of small tweaks to the settings could better protect you. So like the most common one that I see, which is probably configured wrong for I'd say maybe 90% of the users that are out there, would be the media share. So if you create a share for your media, it likely doesn't need to be fully exported with read-write access on a public SMB share. It's likely that it doesn't need that. Now, I get that there's some folks out there that are going to say, well, not for my workflow, and that's fine. I understand. But there's a lot of folks out there that the way they ingest media does not go over SMB. They're either using a Docker container or some other method to ingest media. And in those settings, you don't need that share exported over SMB. But if you do have, let's say, other media clients that are on your network, so say a Kodi box or an MB server, something like that, where the method by which that device is going to get the media content, read the media content, index that content would be over SMB. In that setting, you might want to consider making the SMB export read only. So that way, if you, again, are ingesting media through another method, that's the method that's going to be writing data. That doesn't necessarily have to happen over SMB. That could, again, be happening inside a Docker container. So the share would still be able to be written to by that Docker container. But then for the devices on your network that just need to be able to access that media so that they can play it, well, in that scenario, you just need read access. You don't need write access in order to play media. So you might want to consider for your media share, if you're going to leave it exported over SMB, maybe make it a read-only export. The ISOs share, which you use for VMs, ISOs are essentially images of CD-ROM, DVD-ROM disks that contain the contents and can be mounted like a CD-ROM. So in a VM, you would select this ISO, for example, for your Windows installation media. And then when you start the VM, it thinks that that's a CD-ROM, and it just reads from it just like it would normally and starts the installation process. Well, that share doesn't really need to be exported over SMB, at least not all the time. If you're downloading ISOs to, say, a Windows computer or a Mac or another device on the network, and then you want to copy it over SMB, okay, fine. I understand that. But maybe after you're done, you go and change that share setting back down to either read-only or don't export it at all, because the frequency in which you're probably uploading new ISOs is probably not as high. Now, if you're an IT professional and this is a home lab environment, maybe you're uploading ISOs every day, in which case, go ahead and leave it open. But if you're not, then turning that on only when you need it is just one more way to be smart about security. There's a couple other shares that are worth mentioning, specifically domains, system, and app data. Those are not exported by default. Those are shares that we do create by default, but they're not exported by default, and we recommend you leave it that way. Domains is where all of your virtual disks live for your virtual machines. So if someone were able to get to that share and start deleting, you would lose entire VMs and the contents of them. The system share contains specifically your Docker and libvirt image files, which are really important. You don't want to lose those. It wouldn't be the end of the world if you lost your Docker image file. In fact, there's a process to recreate your Docker image file and then rehydrate all of your apps in the Docker tab. But for VMs, it's a little bit more of a pain because you have to recreate all of your VMs. Even though the vDisks aren't deleted as a result of that, you would have to recreate the VMs on the VMs page, specify what CPUs you're assigning to them, what GPUs you're assigning to them, everything. You just would have to recreate them. You wouldn't have to reinstall Windows, but you'd have to redefine them. And that's just a pain. And then app data, obviously app data is pretty much where all of your Docker containers app data lives. So, if you install Plex or whatever, all of the app data specific to those applications lives in that share. So there's really no reason for you to have to export that over the network. And if that were to get compromised, that could invalidate your apps. It could make it so that apps don't work properly. Okay, and then the last thing worth mentioning is just think critically about every share you create and what users really need to have access to. Consider carefully where you decide to give write permissions, because something that's worth mentioning is that with read-only permissions, you could be subject to data leak, right? So some data that you wanted to keep private is now public. But I would argue that if something like that were to happen, that's a far less damaging scenario than if someone were able to actually purge or corrupt your data. Imagine someone, a nefarious person going in and not even deleting your resume, but maybe just putting some choice words in it. So the next time you just auto-upload it for a job you're applying to, maybe you don't get a call back because they put something very nasty in there. So there's, that's just a silly example. But the point is that if someone can only read the data from a share, there's a lot less things that they can do to hurt you than if they have full read-write access. Now, a couple other things that we're changing in 6.10. Now, some of these were already disabled by default, but just to be clear, SMB version 1, SSH, Telnet, FTP, and NFS will all be disabled by default in version 6.10. If you want to turn these things on, you'll be able to. And with SSH specifically, if you want to ensure even better security, we're adding a new UI method, user interface method, that will allow you to either upload a public key for access. So if you don't want to just use simple keyboard authentication, you can do that, or you can enable simple keyboard authentication through this user interface. So what's important to note specifically about Telnet and SSH is that when people think about the root password and protecting their Unraid server, the first thing that you're obviously protecting is the web GUI, because the root password is what you use to log into that interface and start making changes and configuration changes to the system. But what you can do through the web interface is only a fraction of what you can do once you have SSH access. Now, to be fair, we do have a method of connecting to the terminal through the web GUI. So yes, I know that's true, and I know that that's technically the same thing as doing SSH, but the terminal app and the web GUI, There's certain things that don't work as easily through that as, say, through a full PuTTY client. Plus, you have to actually connect there. You actually have to be in the web GUI and authenticated in the web GUI in order to connect to it. Whereas with SSH, you'd still have to authenticate to SSH, but there's other ways you can authenticate than just logging into the web GUI. But the point is that with console access, which is a generic term for Telnet, SSH, or that terminal client that's in the web GUI, once you're in the console, you are able to do everything, like anything and everything you want. So protecting that is super important. So all this being said, just know that 6.10 has more than just these changes in it. But this is all I'm going to be revealing for today. You'll need to wait for the official release to see the rest of the goodies. So, all right, now moving on from security, I want to talk about another subject, which is 10 gigabit performance on Unraid, because I've been doing a lot of testing with that over the past few weeks. And basically, we did this years ago, but 10 gigabit networks are still more costly compared to their 1 gigabit counterparts. But even though they're more costly, prices for 10 gig have dropped immensely in more recent years. So now, NICs that used to cost, anywhere from $500 to $600 each are easily purchased for less than $100 for 10 gig. And switches, 10 gig switches, we just got one from Ubiquiti. I think it was the XG16, and it was around $550, I think, which is, again, far more attainable than it was years back when NICs alone were, like I said, in the $500 to $600 range, and switches could easily be over $1,000. So the main benefit of 10 gig networking, and okay, this is really on the nose. I know, it's really on the nose. But it's the ability to dump data across the network to a server at 10 times the speed of a traditional 1 gigabit network. So that's the main benefit. But in order for that to work, you not only need sufficient network interfaces, cables, and switches, but you also need sufficient storage performance to be able to write data at the same speed that the network can transmit it. So years back, we did a project actually with Linus from Linus Tech Tips to demonstrate high performance over a 10 gig link. And in order to attain this, we had to make a number of tweaks in the network stack, which have honestly held up pretty well to this day. However, in doing that testing, it only worked when we exported the cache directly, meaning that we were bypassing our user share file system. And when we were using a cache-enabled share, performance would dip a bit. So I want to take 1 second to explain what I mean by this. So when you're writing data to a share, okay, you're going through what is called our user share file system. So the way the array works is every disk in the array is formatted with its own file system. So they're all individual disks. You could write to an individual disk if you wanted to. But when you go browse to a share over SMB, obviously the contents of any share have the ability to spread across multiple disks. So how do we present that in a unified way? Well, it's our user share file system. So what we do is we say the contents of the top level directories for any disk that's in the array get aggregated when they get presented over a share. So for example, media, right? So you have a media share and you've put, hundreds of movies, thousands of movies or whatever in that share. And now you go to browse to that share. Well, what it's actually doing is it's taking the contents of, and I'll give you the Linux path as a reference, /mnt/disk1/media. And then it's concatenating that with /mnt/disk2/media. And it does that for every disk that participates in the share, so that when you browse to the media share, it's showing the aggregate of what is in the media folder or directory on every disk that is participating in the array. That's how it works. So that system that joins all of those directories on different disks together is known as the user share file system. Sometimes we refer to it as SHFS or Fuse. And that's the method by which we're able to present things in a common aggregate way. However, in the past, what we've noticed is that in a 1 gigabit network, you never notice this. It's the performance bottleneck that exists with SHFS and Fuse and whatnot does not seem to present itself in 1 gigabit network scenarios, because the write speed is capped at such a low rate that the bottleneck never has a chance to manifest and display itself. But when you get to a 10 gigabit network, this is where we saw some bottlenecking occurring. And so we wanted to go through these tests again. We wanted to see, there's been a ton of changes in the Linux kernel since then, ton of changes to Fuse since then, a ton of changes to Unraid since then, and storage devices since then. So we thought, let's take another look at this and see if we can prepare Unraid for some other use cases related to high performance needs. Now, since we did those tests years back, there's actually been one major area of advancement that seems to have had a significant impact on performance, and that is a feature known as SMB Multichannel Support. So multi-channel support for SMB is pretty amazing, and it can provide increased throughput, network fault tolerance, and even automatic configuration. When you go to write data over SMB without multi-channel support, only one connection is created to handle this, and it goes through a single network adapter. With multi-channel support, clients can simultaneously use multiple network connections, even multiple network adapters, to both speed up throughput and provide fault tolerance. So we'll put a link in the show description to the Microsoft Docs article that talks about SMB multi-channel support, the requirements, and the benefits if you want to read deeper on the topic. By turning this feature on in our testing lab, we saw substantial increases to both read and write speed, even when going through our user share file system. So let me walk you through this real quick. So the first thing that we had to do was test network performance, and there's a tool or a utility within Linux known as iPerf that we use to do this. So iPerf is not loaded in Unraid by default. If you have the NerdPack plugin for Unraid, you can add this package very easily using that. And iPerf is used to just purely test network performance. So the idea is take all the other elements out of the equation at first and just make sure that from a pure networking perspective, how fast can we go? Like, are we going to be able to attain 10 gig? Because if that isn't solid, if we're not getting that from the network level, then doing a write operation over SMB doesn't matter. Because if we're not hitting it at the network level, we're definitely not going to hit it when we're going through a file sharing protocol. So doing iPerf, the first test that we would do is using a single stream. So when you're running iPerf, there's just a bajillion different switch statements that you can add to it for all these different things. But the reality is that you don't need very many to do a basic test. And the most basic version of running iPerf, most basic method, uses a single stream, which means there's only one connection made from the client to the server to send the data. And doing that from a Windows 10 box to an Unraid server, we achieved 7.8 gigabits a second. Now it's not bad. It's not full 10 gig. It's roughly 80%. We're almost at 80%, 78% if you want to be precise. But when we increased the number of concurrent streams just to two, we bumped it up. Now we saw 9.4 gigabits per second in aggregate throughput, which is really, really solid. So we were also interested in testing this between two Unraid machines. So Windows is obviously an important test case, but what if you wanted eventually to sync data between two Unraid servers at an incredibly high rate of speed? How would that perform? Well, what's amazing there is that doing iPerf tests between the two Unraid machines, no Windows being involved, we were able to get a full 9.4 gigabits per second throughput with a single stream. Go Unraid! So this clued us in on the possible benefits of multi-channel, because that's exactly how multi-channel works is by adding a secondary stream, right? So we were curious, if we turned that on, would we get the same benefit to SMB transfers as we saw with iPerf? So once we completed the network testing, we ran through a number of different read and write performance tests through the network. Again, no SMB multi-channel yet. And initially the results were not what we expected. Write performance was definitely being bottlenecked, and neither the network nor storage layers seemed to be to blame. And clearly with iPerf, there was sufficient network performance available. And between the NVMe storage devices and the Btrfs RAID 0 cache pools we were using, we just knew that storage wasn't the issue. So this is when we decided to turn on the SMB multi-channel feature, and in doing so, we saw some pretty dramatic improvements. First and foremost, we were able to fully saturate the 10 gig link in our Midwest lab when copying data from an Unraid server to a Windows machine, even when going through a user share. We saw a significant performance increase as well when writing to a user share from Windows, but it didn't fully saturate the 10 gig link, even when we bypassed that share and wrote directly to the cache. We also noticed that Unraid to Unraid performance wasn't what we expected either, but that was, again, in our Midwest test lab, and we think that might be related to the hardware we chose to use for one of the testing systems. And this is a lesson that we learned, is that it's important that when you're testing in a 10 gig environment, the hardware you're using becomes so much more important to ensure good results. And one of the test systems that we were using, one of the Unraid servers, was using a lowly i5 processor from a few years back, whereas the other system was an AMD Threadripper with more cores than a semi-truck has wheels. So we were pretty confident that the Unraid to Unraid testing we were doing might have been being bottlenecked by a lack of performance on the underlying hardware. But thankfully, our friendly Flying Dutchman, known as Bonnie NL from our community, also had a pretty amazing lab environment to test with and a few additional tweaks that he wanted to apply. And in doing so, he was able to attain full 10 gigabit throughput bidirectionally to the cache from a Windows client. Now, that was bypassing user shares, but again, this was the first test in these last few weeks where we were able to get full 10 gig a second to anything bidirectionally, right? So that was really huge. But what was even more amazing was that when we did do the test through a user share, he was getting around 800 megabytes a second in throughput, which is pretty close. I mean, that's 80% of full saturation. And again, for going through user shares, that's not bad. Like, it's not the best in the world, but it's not bad. So what does all this mean? Well, it's our goal in the near future to provide a means for high performance use cases within Unraid. Establishing solid 10 gigabit performance to SMB shares is a key step towards that goal. So this was a really good set of tests we ran over the last few weeks, and we've got more work yet to do on this. But the fact of the matter is that from a network perspective, we think we're pretty darn well tuned. We're able through iPerf to get 10 gig a second throughput from multiple client devices out of the box because of the settings that we've put for the network tuning in Unraid OS. And on top of that, another thing that's worth mentioning about 10 gigabit performance, because I know there's tons of people that talk about 10 gig in Unraid, not as many as people that use 1 gig, but still there's a lot of people that love to talk about 10 gig, and it's a tricky beast. 10 gig is a tricky beast, and sometimes folks will get obsessed with tweaking certain values that in the end have minimal impact to overall throughput. So a good example of this is jumbo frames. So some folks think that this alone should double or triple their throughput, but that just isn't the case. And in our testing, enabling jumbo frames took our iPerf tests from 9.4 gigs a second to 9.8 gigs a second. So while a 400 megabit per second improvement isn't bad, we're talking roughly 4% more performance. So if you want to squeeze every ounce out of your network, by all means, turn it on. But if you're not getting anywhere near max throughput, this isn't the feature that you need to be spending your time on. There's something else wrong, either with your cabling, your NICs, or your switch, that's causing issues. So, again, don't expect these huge gains in performance by turning something on like jumbo frames or by tweaking the transmit or receive buffers. I mean, there's things you'll see some gains there, but they're usually minimal in the grand scheme of things. Another thing that's worth mentioning is sometimes you'll do a test and you'll make a small change and then you'll test again and the results will be abysmal. But what you won't have done in between is resetting the ports or the NICs or the server or anything like that. And I will say that in doing all of these tests, we noticed that sometimes when you're doing all these changes live and you're not rebooting or resetting in between, that sometimes you're going to get a false impression about the results thinking, oh, well, that didn't work. But the reality is you just needed to reboot the server or reset the NIC or, reset the interface, whatever, and that would have fixed the problem for you. So just make sure that when you're testing, don't go down the quick and dirty path. Take the time to reset everything for every test just to make sure that you're in a clean slate. Now, last thing that I want to mention before we wrap up this episode. I know you guys are probably wondering how to turn this feature on, and I will be writing a blog post in the weeks ahead to document how you too can test this feature out. I don't want to disclose it today because honestly, there's a couple of complexities to making this work solid. In addition, just know that what we've tested in a lab is very different than what we would stamp our seal of approval on for everyone out there to use. And I know that early on with multi-channel, obviously everyone out there was thinking, oh, this is going to be a huge performance gain. But I know that there was people out there on other platforms that when this was turned on and all these features were turned on, that it caused some other issues for them. So what we don't want to do is just turn this on for everybody and it benefits the handful of people that have 10 gig and ends up causing problems for a bunch of people that don't. So we need to do some more testing and put some deeper thought behind how we want to implement something like this before we turn it on for everyone. But like I said, in the next few weeks, I'll be writing a blog post. I'll document how you can set this up if you want to test it on your own Unraid server. Just know that you'll be testing at your own risk. We're not, providing direct support for this feature yet. So it's just something that we'll document for you guys to play around with if you want to experiment and you have a 10 gig environment. So I think that about wraps it up for today's episode. I really hope that everyone out there has an amazing 4th of July. For those that are in the U.S., happy Independence Day. For the rest of the world, just happy July 4th, I guess. So thanks everyone for tuning in, and we will see you guys next time.